All right, let's get right into it because this is a puzzle that's been driving pretty much everyone in AI a little crazy. We've got these incredibly smart models, right? They can pass the bar exam, they can write amazing code, but then they turn around and completely fail at a simple task, and for no reason you can see. So this isn't about making AI smarter. It's about figuring out why they're so weirdly, surprisingly unreliable.
So that brings us to the big question. Why? You ask a top-of-the-line AI to do something, and boom, it nails it. Perfect. So you ask it to do the exact same thing again. Same prompt, same setup, and this time it just completely faceplants. What is going on?
And see, that's the real kicker here. Because if an AI just wasn't smart enough, it would fail every single time, right? And if it was smart enough, you'd think it would succeed every time. The fact that we're getting this mix of outcomes, well, it tells us something else is going on. Something hidden just under the surface.
Let's call this whole thing the AI contradiction. The researchers who studied this call it mixed outcomes, and believe me, it happens way more often than you'd think. We're going to really unpack this and look at what happens when a perfectly capable AI just goes off the rails.
And this slide just lays it out perfectly in black and white. On the left, a model gets a task, create a GitHub milestone. Done. Super efficient, just 6 steps. On the right, same model, same task, but it takes a crazy 38 steps, gets totally lost, and in the end, fails. I mean, how does that even happen?
Yeah, and this is not some rare fluke. Looking at thousands of these AI task attempts, a pretty shocking 22.5% of the time, we see these mixed results. That means for more than 1 out of every 5 tasks, the AI can do it, but it's basically a coin toss whether it actually will. That's a huge reliability problem.
So, how in the world do we solve this mystery? Well, the key is this idea that researchers came up with called the canonical solution path. I just like to call it the golden path. It's kind of like a secret map that all the successful AIs are following, whether they even realize it or not.
The thing to get here is that for pretty much any task you can think of, there's a best way to do it. Think of it like a hiking trail, the one that's all worn down because it leads straight to that amazing view. Sure, you could go wandering off into the woods, but that trail is the most reliable way to get there. This golden path is just the AI version of that trail.
So let's make this real. For that GitHub task we just saw, the golden path is super simple. Step 1, get the data you need. Step 2, write the file that makes the milestone. Step 3, say you're done. That's it. Those are the essential moves. Success is all about sticking to that playbook.
Which, of course, brings up the next question. If this golden path is so clear, how on earth do these super smart AIs get so lost? And the answer is fascinating. It's not one big dramatic mistake. It's more like a slow, gradual drift into total confusion. And this chart, it shows you exactly how it happens. At the beginning of a task, the runs that are going to succeed and the ones that are going to fail look basically identical. They're both sticking to the script. But then as things go on, this tiny little gap starts to appear, and it just gets wider and wider. The failing AI isn't making one giant wrong turn. It's just slowly wandering farther and farther away from the path.
And this quote from the actual research paper just nails it. For the entire first half of the job, you literally can't tell which AI is going to fail. The little mistakes are so small, so subtle, that they only add up to a real problem way later in the game.
So how does a tiny little drift turn into a complete and total failure? Well, it's like a domino effect. The researchers found that taking just one step off that golden path makes it 22.7% more likely that the very next step will also be wrong. That's huge.
It's a feedback loop from hell, really. A tiny mistake creates a little bit of confusion for the AI. That confusion makes another mistake more likely, which creates even more confusion. And you see where this is going. It's a spiral that takes a perfectly capable AI and just leads it completely into the weeds.
Okay, so this all leads to a really important takeaway. This whole discovery forces us to think about 2 totally different kinds of AI failure. And understanding the difference is crucial for actually building and using these things.
So on one side, you've got a capability failure. That's easy. The AI just doesn't know how to do the thing. It's like you not knowing the recipe for a cake. But then there's a reliability failure, and that's what we've been talking about. The AI knows the recipe perfectly, but because of some random chance, it gets distracted and swaps the salt for the sugar. It had the skills, it just fumbled the execution.
So if the problem is basically that the AI is losing its way, how do we fix it? Well, the answer isn't always to give it a bigger brain. Sometimes it's just about giving it a better compass to keep it pointed toward that golden path.
So what do we actually do about this? The takeaways are super clear and pretty powerful. First, we've got to watch these AIs while they're working and look for that drift. Second, when we see one starting to wander, we can step in and nudge it back toward the path. And finally, this means we need to totally rethink how we measure if an AI is good, right? We need to focus less on just what it can do and more on how consistently it does it.
And get this isn't just a theory. The researchers actually tried a super simple fix. They just had a monitor watch for AIs that were drifting and then restart them. And the result? It boosted the success rate by almost 9 percentage points for the tasks it stepped in on. And that's without even touching the AI model itself. That's wild.
And really, that's the big idea to take away from all this. The race to build better AI isn't just about making bigger and bigger models that know more stuff. There's this other, incredibly important job, reliability engineering. Just by being smarter about how we guide AIs, we can unlock so much more performance from the models we already have. So I'll leave you with this question to chew on. We always assume the next big leap forward in AI is going to come from a model that just knows more. But what if the real revolution comes from an AI that's just more consistent? One that doesn't just know the recipe, but one you can trust to follow it every single time.